Good day, everyone. You're welcome to Structured Programming class. In today's class, we are going to look at the classification of programming languages. We are also going to explore the characteristics of this classification of programming languages, where we are going to look at the low-level programming languages and the high-level programming languages. We are also going to learn about the phases of program development in our day-to-day programming experience so that we can be able to also grasp the structured programming concept so that at the end of this session you students out there can be able to identify the differences between these classification of programming languages such as the low-level programming languages and the high-level programming languages. You can also be able to describe the characteristics of a good program. That is what takes a program to be a good program. We are also going to be able to describe this as well as explain the structured programming approach or concept and the benefit related to this structured programming approach so that you can be able to apply the knowledge you acquired in this very module in order to analyze and document a program's lifecycle. So we have been working with program, we have been hearing program, and what is this program? What is it all about this program? Program we know is a set of sequence or is a set of an instruction code that is written in a particular programming languages in order to instruct the system what to do, when to do, and then how to do it. Programming languages helps programmers to communicate between themselves and the computer or amongst themselves and the computer system. So also in human nature, we have natural language, which we use to communicate amongst ourselves, like English language, which is an official language that we use in this country to communicate with each other. We have our very different dialects that we use to communicate in our various houses and homes. So these programming languages helps you to communicate with the system, and thus it being classified into low-level and high-level programming languages. So looking at this, we are talking about what is a program. We said it's a finite set of a sequence that instruct the computer what to do and how to do it. And humans, we know we use natural language in order to communicate amongst ourselves, whereas in a computer system we use a programming languages in order to communicate with these devices. So writing instructions using what? Using a specific programming language is necessary, and these programming languages we know them. We have a programming language like C, C++, Python, PHP, Java. So we have been working with just a lot of them in order to communicate with these devices. So now the classification of these programming language, which we have had an overview during an introduction. We said we have low-level programming languages and high-level programming languages. The low-level programming languages, they are what? They are machine dependent, they are efficient, and then no translators are needed. So example of these machine languages or high level language, sorry, example of these low level programming languages, we have machine language and then we have assemblers, right? Where you need what? You need assemblers in order to translate, or you need translators or interpreters in order to translate in between these machine language and assembly language, or machine language to assembly language, because assembly language use mnemonic instruction code that you exactly understand by the machine and also the user. So the assemblers used to translate those mnemonic code into what? Zeros and one to a what? Machine understandable languages. So we have a high level language, they are machine independent, so they are easier to write, easier to understand, easier to debug, and they are very portable. You write them here, you transfer them to another system. They pick example of those we have. In FORTRAN, we have COBOL, we have Java, we have Python, we have C, C++, PHP, and just a lot of these programming languages that we use today are high level programming languages. So under the what low level programming languages, we said we have machine language, we have also assembly languages. This machine language, they are directly understood what by the computers using the binary numbers of zeros and ones. Then they are very efficient. They doesn't need any translators. So that's the part of the advantages of these low-level programming languages. So also we have a high-level, but we have also their disadvantages of that. They are too bulky. Like you cannot write within a small piece of space. You cannot write a meaningful program. So you need a very big space. So also they are also prone to error due to that their bulkiness, and then they are machine dependent. When we talk about the assembly languages, we are talking about the what using the mnemonic. Mnemonic in the sense that we know we have been having something like our ants, like soap, like move, like STA, LDA. So all these things are used in order to communicate with the system to do these assemblers, and they used to translate. They used to interpret. For instance, if you're using this type of program, if you want to add any numbers, you use ADD. If you want to subtract any numbers, you use SUB. If you want to store any given number, if you want to store any register to a register, because then they use a register, right? So if you want to store, you use what they call STA, which you can use to what to store the value of probably X into C register, that's use SDA. So we have LDA, which is the load to the accumulator. If you want to load certain data into another data, you use LDA. So these are examples of mnemonic instruction that they use. So the advantages of these assembly language, they are memory efficient, and then they are faster in execution because due to its closeness to the what to the hardware devices, so they are very fast and efficient. So looking at the disadvantages still is that machine dependent, that they are very expensive to be developed. So looking going by this now, I believe you can be able to outline the similarities between these machine languages and then assembly languages. The similarities, they are all machine dependent, so they don't need any translators. So these are some of the similarities of these uh, assembly and machine languages. So also high level language and low level languages, you can be able to at least provide the difference between them or amongst them. You can take maybe for instance we are asked what provide the difference between low level programming languages and high level programming languages in a tabular form. So you can use that by saying uh, low level programming languages, they are machine dependent. High level programming languages, they are machine independent. Low level programming languages focus on the machine instructions, while high level programming languages focus on user friendly abstractions. And then low level programming languages, they are very cost to implement or to develop. High level programming languages is less to implement or developed. And then in terms of understanding low-level programming languages, it's very difficult and hard to understand. And then the high-level programming languages, they are very easy and then easy to learn and understand. That is, they are user-friendly to say, for instance. So in terms of example, we can say high-level, low-level languages have something like machine language and assembly language. High-level language have FORTRAN, C++, C, Python, and what. So these are the differences you can provide in a tabular form. In terms of the differences between these low level and high level programming languages. So let's look at the characteristics of these high level languages. They are human readable, so you can be able to read it humanly without any issues. So they are very easy to read and they are very portable. The portability here, it means you can be able to work on here on this system and then transfer your particular program to another system to work with, and then change it to another system again to work with it. So they are very, very portable and they are object oriented in nature, means that they can allow for code reusability in essence. So you can use and reuse your code. Use your code on this particular system, use your code on another particular system, use your code on the different system entirely. So these are the some of the characteristics of these high level programming languages. So the advantages also of high level programming languages is that they are easy to use, they are easy to understand, they are easy to manipulate, and they are machine independent. So these are the advantages of that high level programming language. So what of the low level programming languages? If you look at it here, what they said, they are very slow in nature, and then they occupy less memory, and then they require what? Translations, translators, right? In machine, in low level language, it doesn't require translators in order to translate into machine language. But here you require translators because you develop a program that is not machine friendly, is not understood by the machine. So you need translators in order to translate this your English like programming into what? Into machine understandable language that is in forms of zeros and one, just as the way assemblers does to what? To the machine languages. So this is what is all about high level programming language, low level programming languages, the program, and so we have the characteristics of a good program. What are the characteristics for a program to be a good program? This is what we are going to look at here. And we have in number one, we have the portability. That is the ability of a program to work across different platforms. So this is very, very, very important. You cannot expect you have a program in a particular system, and that program cannot be able to run on another system. So such program is not portable. To say they are not friendly, they are not movable, so they are not reusable. So it's very unfortunate. So that very program um, is not a good program. So who can relate this issue of portability here? So please, if you can relate it, you should let me know. And I has issue like this, an experience on this portability. When we were in school, a task was given to us to calculate the factorial of a given number, and then it was a very hectic stuff that you need to write your code on paper before you get into the system and then implement it. And going into the computer lab is also a different thing that you need to go only in the night when school generator is on. So, though if practical is scheduled to you, you at least meet your system like tag with your own personal matric number. So we went there, we coded, we ran the program using Visual Basic then. So the program was running, we do all the necessary labeling, text box because that's how we use does this. So you cut in the VB editor, you run the code, it will now you will now see the interface including the label, the radio, the command, the text, all these stuffs are there. So my program was running perfectly. I knew it was running, but unfortunately, when it was picked by a friend of mine to take it into another system to see how he can be able to manipulate, because we were running out of time to get his own also running, and that system refused to work well. So, and we are like shocked. What's the problem? And we know that that problem lack portability. So please, no matter what, really make sure that your program is very portable to work or to be executed on any particular PC, please. Then the second one is reliability. That is, delivers must be able to deliver consistent outcome. That's your system. If your system cannot be able to deliver consistent outcome, it means that particular system is not a good program. What it means by delivering a consistent outcome here, in essence, is that if, for instance, I'm developing a program that can calculate a given factorial number, and we know if you have typed 3 in a factorial number, you are having 6, right? So it means if you typed it now, it gives you 6. Later you write 5, it gives you 6. So you should not expect the outcome from 5 inputs should give you a different result. So if certainly it gives you different results, it means that program is not a good program also. And we also talk about the efficiency. If you're talking about the efficiency here, we will not forget about the cost and then the time of the time effectiveness here. So we must put them into consideration. The cost here, like the program under development, will not be what too costly. So it must be what cost considerable. Are we together? So also we're talking about the time effectiveness. The time effectiveness here, it means if you are calculating a factorial of a given number, excuse me. So let's assume it's 5. you are inserting 3 in a factorial number. Let's assume the system prompt you, please enter the value to calculate the factorial. You enter 5. You know, there are some genius, like if you just give them the parameters as you're just finishing, like the area of a cycle where radius is 20, answer is just coming out. So your system should be more than this, in a way that if you just hit on calculate, you are expecting to see result. Even we did just a nanoseconds, right? We know nanosecond did not even reach a second, right? So within a nanosecond, you can be able to see your outcome on the screen. So the next one is what, the readability. Your system should be able to be user friendly and readable to all for all the reusability, and then for all the user guide. The readability here is that on board programmers aspect, and then the user understandable aspect. So if we talk about the programmer developers aspect, is that you should give a room for anyone that is coming to reworked on the program to be able to understand what you have done by probably using commenting, right? You have a very clear write-up that one can be able to come and then get what you are doing. So in terms of the understanding, or that is in terms of understanding, so your system should be able to be understood by each and every one of the system without going much or harder training. So we can testify most of these programs that we worked with today, they doesn't really require too much training. Like we worked with them on our own, right? We worked with them with our own because of its ability to be readable. So that's it. And also we have flexibility. And flexibility here is that the system should be able to be what, to be adaptable, but adaptable for changes. That's in essence, you should not expect after you've deployed a program and the client say that they need some changes, and then you say, for me to change this thing, I need to do all this, I need to start afresh. And no, it means your program is not a good program. Whenever you have a good program, once changes is required, you should be able to do it. I remember I had an issue. I was trying to deploy a site for one microfinance bank like this. Then it was done quite all right. It was deployed, no problem, no issue. But in the while they were using, they say, they want to add some features there. So how are they going about it? I say, fine, it's not a problem. Just, yeah, give them requirements, collected data, and see how we can be able to implement it. So it's not that difficult. Just try to make sure you have done the right thing from the beginning of the program. If you did not do your job well at the beginning, it means you cannot be able to succeed in this journey. So that's in terms of the flexibility. When we are talking about the phases of program development, we are talking about the stages in which one can be able to follow in order to actualize the problem in questions. This is we are talking in essence about the problem definition, or in number one we have a problem analysis. So in problem analysis, you are going to define your problem. You are going to ask yourself several questions, and that program you want to actualize, is this something worth of doing? What is the expected input, and what is the expected output? What are the characteristics of the program that you are going to develop, and what are the source of data of the program you are going to develop? So all this analysis is required of you to answer these questions. Then you have your input, you have your processing, you have your output. All is coming at what? At the phase of problem analysis. Then after that, you have algorithm development. So in the algorithms development, we know these are the step-by-step processes which you can follow in order to achieve that process. So after you have defined the problem, so you need to develop the processes again. Why? That's in definition. You have asked yourself, how are you going to develop this problem? So this the answer now is coming at the algorithm development. what those processes that you can follow in order to actualize this, the tools you require to do that, the data you require to do that. So all these sort of processes you need to do them here. So at this phase is asking of you in essence to describe the way and manners in which you are going to take out your program. Then we have program design. At the program design, you have this is where you can be able to design your program on paper. Like you have the flow chart, you have the pseudocode, you have the DFD, all these sort of designs you need to get them here. I personally used to work with pseudocode and algorithms here. That is why if you can see from the caption, we have captured pseudocode and algorithms. And we know in a pseudocode is an English way of writing a program just in a plain English without any code, without anything. And you can use a number just like the way your IDs are coming with numbers. So you can also use numbers in that. Example to say you are developing a program that can calculate area of a cycle. You know, in doing that, you have already done that at the at different phases, at the problem definition, at the algorithm development. So you have your input, you have your output, you have your processing, you have your storage. So at the pseudocode, you can use just maybe line number 10 to start the program, like number 20 to accept input or enter input, to line number 30, probably you say area is equals to this, line number 40, probably you print output and so on. While your flow charting is the process of how you can mimic this your program into a pictorial representation of what you are about to code or you are about to develop. Like for instance, you use these very fundamentals or famous uh, icons like to say you have ovals which is used for input. You have parallelogram which are used for input out sorry ovals used for what? For the starting and for ending of the program. Parallelogram are used for input and output. Rectangle are used for storage, and then you have diamond shape which are used for what? For decision. So you can use also these all sort of programs or all sort of diagrams in order to what? Have your development. Like I personally prepared in whatever problem I'm developing, I plan to do the pseudocode and algorithm, because as you're doing it, it's going to soften your way of implementing your real program. You are getting to understand the inside of your program. So this very phase is necessary for one to develop a very good and very useful program, very responsive program. So we talked about the coding at number 4 of the phases, or at stage number 4. The coding, this is where you're going to write the instructions. You are going to write your instruction at the coding. So all it requires of you for the implementation, you do them there. So we have the compilation. Remember, at the beginning of this class, you have grouped your work into various functions or into various modules. So here you are expected to what? You are expected to bring those functionalities you have grouped into different pieces, group them together, see how you integrate them, see how they can be able to work with each other. Then after you have compiled, then you run what we call testing. You have done what we call unit testing before each and every of these modules. They run at their various testing, and you have satisfied that these units or these modules have been working very perfectly. So at the testing and debugging, now you come you bring them together by the use of integration, and then you try to see to run what we call system testing to see all these functionalities, they agree to each other and they are working perfectly without any issues, and you have your very perfect program ready for work, ready for use, ready for deployment. Then you have what we call documentation. At the documentation, you have two ways of documenting your work. You have developers documentation and you have user documentation. At the developer documentation, this is where you do your documentation, like you have your documentation from the coding, like you have at each line of code you have a comment, or at each level you have a comment. This is where you've inserted input, this is where you have inserted functionalities, this is where you have inserted processing, this is what all these sort of documentation is required of you. The reason behind this is because whoever that is coming to use this very program can be able to what can be able to uh, read out your program, understand the coding, be able to reuse the problem or the program. That is the reason of having high level programming languages, because of its readability, right? So at the user documentation, this is why we are having a user guide in all aspect of programs or softwares we have been working with, all applications that we have been working with today. You can see we have a documentation like user guide documentation, which guide the user on how to operate with the what, with the system, or how to go about the application or the system. So this is very fundamental for your program to go through this very phase. And also we have what we call maintenance. This of course you cannot ignore that every program must be subjected to maintenance. Like you need to be updating your program at every point in time. You see how the program is running, try to integrate something. If you see any feature, you try to implement it here and see how this program are what are been able to update. That is why we are having issues of versions, right? We have been having a series of version. We have been seeing almost the programs that we have been working with. Sometimes the applications get stuck that you need to update either your license or either there is a new features that is what implemented in the system. So you need to update to a higher version. So this is very fundamental and is very necessary. This phase is very useful. So if you have any program that you need to go through, make sure that they're subjected to each and every of these phases. Assuming if probably task is given to you to that you should respect these phases of programming language and carry out that project. I believe it's not something that is going to be difficult. You can be able to document that from the problem definition, algorithms, algorithm development, program design, having the coding, the compilation, the testing and debugging, the documentation, and of course the maintenance is just something scripting. So this is what we have at the phases of program development. So let's look at the structured programming concept. We have been talking about the program, we have been talking about structured programming, but what is that structured programming that we have been talking on and on and on? What is it? How does it define? So our structured programming is here to assist us with the way of breaking down in each and every given task. Like a program is given to you, so it's expected of you to break this program into pieces, break them into unit, break them into modules, break them into functions, so that you can be able to do the programming at each module or at each phases of this grouping or at this unit. That is why we are having unit testing during the during that program development phases. Are we together? So this your structured programming allows you to break a complex program into what a smaller unit of program for easy programming, for easy development, and so on. So that's what program structured programming is all about, and we have characteristics of this structured programming. But before then, we know while we are what trying to group this complex program into a unit, we have something like we said we need to have input, we need to have output this. So all our input and output are what are going to form a kind of a variable, and we know our variable are containers in which we use to store it in values in which we use. We called in for values during processing to the output, right? So now you have these variables as local variables which you are going to use them within the system, and we also have global variables. So we also have you need to define or your one of the characteristics is the what we have a logical or minimum global variable. So all these are what a form of character, a form a kind of characteristics of a what of a structured programming. And they use a system programming languages such as C++, Python, Java, and so on and so forth. So in short, our structured programming are high-level programming languages. So this is what we have as a structured programming. We also have the advantages. That is what makes us to what can we benefit from this structured programming. Why is it necessary we need this structured programming? We need structured programming because of its user friendly in nature. So it is easy to understand, it is easy to maintain, and they are very portable. You can work with any structured programming on this system, then transfer it into another system. You still work with it. You take it to another system. You still work with it without any issue, any problem. Just at a go, you have your what? You have your program with structured programming or any structured programming. The disadvantage here, of course, we know anything has to do with high level programming languages require translators. So they are translator dependent. And they are time consuming for what? For a very complex program. That is why you need to what? To for all complex program, you need to what? You need to group them. So that is the reason that is the complexity here. That is the disadvantages of the structured programming. So we have come to the end of this program, but before we conclude this session, let's quickly recap what we have covered so far in this module today. We have talked about the program. We have seen the classification of this program considering the low level programming language, the high level programming language. We have given instances of high level programming languages. We have seen how it works. We have seen example of low level programming languages. We've tried to look at the similarities amongst this example of low level programming languages, such as the machine languages and the assemblers and the assembly languages, where we say they are machine dependent, they are very cost, they are memory efficient, and so on and so on. We also look at the characteristics of high level programming languages, also considering the differences between these high level programming languages and low level programming languages. If we are to ask, provide these such differences on a tabular form, you can be able to do that, I guess. We also did not forget about the qualities of a good program. That is, one must adhere for to these very qualities or characteristics of a good program, ranging from the portability, readability, for the availability, for the efficient, and debugging. So all this is what we have looked at. Then we also look at the structured programming concept, where we say it provides the ability for one to be able to break down his complex program into units program, into modules program, into group them into smaller pieces, group them into functionality, so that he can be able to have a simple way of developing and executing a program. So we've looked at the advantage and disadvantages of structured programming, and then we said we can conclude like programming languages we know are the key component, are the key component for one, or key medium for a computer to be what to be communicated to, for one to communicate with a computer. Without programming languages, you cannot communicate with the programming language. So that's the key functions of what programming language is. So understanding the phases we have outlined during the program development is very essential, very important, that you need to undergo through for one to be able to develop a program from the beginning to the end. And of course, mastering the qualities of a good program can help you to develop a very stunning and astounding program. So at any point in time, and the structured programming enhance clarity and then adaptability in whatever you are doing. Don't forget that programming is all about consistent, program is all about efficient, program is all about practicing. Keep practicing, don't relent. Whenever you have issue, don't forget to knock at our door. We are always here for you. We will guide you through to become a really computing student. Thank you for being with us. Remain blessed.